Well, hello everybody. Thank you for joining today's session. This is a session on using FME to interact with web services and APIs. My name's David Eagle from One Spatial, and thank you for joining us. Here's today's agenda. We're going to look at what is an API and what are web services, and then we'll look at a few ways of consuming data into FME from these sources. So I've got a few examples to show you and take you through here. I work for a company called One Spatial, and we've been working with safe software now for quite a few years, and it's our specialism in terms of products that we resell, third-party tools that we resell. We also work with Latitude Geographics, who make Geocoding. And we service a number of customers globally with these products and also our own tools as well. Lots of different industry sectors that we cover. We've got a number of consultants who have different specialisms. What you'll be interested in is our certified professional and trainer status, and we maintain those capabilities. We're assessed every few years to make sure that we are still able to retain those certifications. Safe Software have been around for over 20 years now. They're a very established vendor in the market, and they interact with many different data environments, whether they're in the proprietary arena or open source. Just a few logos down there to show you some of the environments that Safe integrate with their FME product. Connect, Transform and Automate is the tagline for FME, and the three main tools that Safe create are FME Desktop, FME Server and FME Cloud, and really it's the same underlying engine inside those applications that does the work. And the main difference is the way in which the product is deployed and some of the capabilities and interactions that you have with the FME product stack. A few things that we offer. One of the very successful things that we do is help customers evaluate FME effectively, rather than just giving you a trial license and sending you off to go and have a go with it yourself. We will make sure that you get full value out of your evaluation. We provide consultancy and dedicated training services, whether they're bespoke or private, in your offices, and we provide technical support to all of our annual maintenance customers. So, to get on to the topic of the day, the main thing really is what is an API. That will help us understand how we can interact with it. Well, it's an application programming interface. That effectively means that it's a way of communicating with a system or an environment that somebody's already built. And it includes all of their rules and protocols to allow us to interact with that environment. And it can be sometimes seen as a handshake. So effectively what we're doing and what we will do with FME is communicate directly with that environment, and using the rules that are defined by the person who created the application or the interface, will exchange information using those protocols. Invariably in our discussion, what we're keen to do is to get access to some data. Web services are similar, though not the same. Effectively it's a way of communicating between a couple of devices, and there's a number of different languages that web services often post in, and often the language that's used, whereas it might be a term like REST or SOAP, underneath that overarching capability is often data in an XML structure, for example. So XML and RSS are two very common ways of feeding information and data between systems. And in the geo environment, a couple of services that we're very familiar with are effectively from the geospatial consortium, the Open Geospatial Consortium, or the OGC, and they're web feature services and web map services, and that's effectively vector data on the web feature service and serving up of raster data via a web map service. And you can have a look a little bit at some of the source information there on Wikipedia to get a feel for them. If you come from the geo arena, though, you're very familiar with this. If you come from the non-spatial arena, care more about just tabular data transfer, then perhaps you're familiar with working with APIs, perhaps a little bit more. So let's start looking at a few examples and how we can set up communication from FME to these kinds of environments. And I'm going to do that with a few examples. This one here is Elgin. They're an organisation that provide access to roadwork information, and you can find out more directly from them. We're not endorsing them, we're just showing that as an example. Roadworks.org is an interesting site to take a look at. If we bring that site in, you can see that there is roadwork information available in all sorts of areas. So if we go to the sort of Cambridge area, which is where our headquarters is based, and wait for the map to refresh, hopefully what we'll start to see on screen is a series of roadworks that are updating. And these come from assorted organisations, so it might be a utility company, it might be the local authority, it might be the Highways Agency, the Highways England, any number of organisations posting information that Elgin are scraping. And what would be interesting to do is to access this data through an FME script, and you might want to do that because perhaps you may want to update your own web map system with information from here. One way of doing that is to write an FME process to consume the roadwork information on a schedule and write it into your environment, whatever that might be. So if we go and have a look at an approach to doing that, we could open up an FME process, and if you want to get access to the API information that Elgin publish, then you need to get in touch direct with them. I should also note that there is a fee to access the information, depending on what type of organisation you are. So here, for example, is an FME workspace, and what we're doing in this part of the process is creating a trigger feature. And that trigger feature is actually a bounding box. The requirement of the Elgin API is that you pass in a bounding box of an area that you might be interested in. In this case, it's just a coordinate list. So we have a lower left and an upper right in British National Grid, and we're going to create that feature, and we're also passing in some information. In this case, it's an organisation name that has registered to use the service. You can see that we also need to pass in to the SOAP request a set of coordinates that we're interested in. So the XML templater, if we dive into here, allows us to define the requirements of the request. In here we can see that we're passing in the organisation name, a password that we're passing in as a parameter, details of what we want to get back, and the string of X and Y's that represent the query. And we then are going to pass that up to the service via the HTTP uploader. So we hit the target URL and we pass in the SOAP request in this case. So if we just go back to our slides, we've got reference in here, I believe. Let's just do it through the link. There we go, bring in the API rules. And you can see that there's details of how you can communicate with this service. In this case, what we're doing in here is a post request, so in which case we would go and have a look at the appropriate details in the API rules. What we'll end up with is getting back some information about the roadworks, and I'm just pushing out the raw XML, and you could write that out to a text file if your system requires an XML to consume it. What I'm actually doing is then breaking that feature up into a series of events. So if we just run this process as is, and we'll pass through the request boundary, upload the bounding box and the request, and we can see that we've got 159 features pulled back, and all I've done is pushed it into the data inspector. So here, centered on this location of Barnsley, you can see that we've got a whole number of requests, and I've split them out based on the query extents, which is the bounding box that I passed in, and more importantly what came back. So we can find out what Barnsley Council are publishing, 99 bits of information about roadworks, what type they are, and whether it's in this case traffic control or signalling information, and we can see there's some resurfacing going on to resurface some footways, and right down to organisations like gas and, in this case, power and telecommunications information from Virgin Media in that case. So there's now nothing stopping you from scheduling this process to write out to maybe a file-based format or into a database on a schedule, and that could be going every hour or every 10 minutes or every day, running overnight, loading your environment and allowing you to then connect to that data, rather than you having to write some heavy or dedicated program that would allow communication direct. This may be an interesting way of getting access to that roadwork information. A lot of applications, third-party tools, actually give you access to those environments via an API. We do that with our own tools, the One Spatial Management Suite, so we have a component called One Integrate, and we use that to manage data for national mapping agencies. We also use it to infer missing pipe assets for organisations like utility companies, and a lot of other things. And the key thing here is that what we can do is use FME using exactly the same methodology to construct a request using the XML templater, and then pass that request to that third-party tool and communicate via the API. In the case of One Integrate, we can trigger a session to go and do some pipe inference against a bunch of pre-configured rules, and then we can pass back to FME the status of that task, or even trigger the process to read data from the database that has been written by another tool. So that communication approach gives you some really powerful capabilities to interact with other applications in your environment. If we look at some of the other API examples that are out there, an interesting one that I've discovered for postal code analysis and querying is the UK postcodes API. This is just a small system that was set up by an individual, and you can interact with him on Twitter if you wish, but you can see here that it's a simple tool. You can punch in a postcode that you might have, so put in a postcode in Cambridge, and run a query against it, and it gives us the details of where it is, a little bit of information, and some links to a few interesting websites like Openly Local and GeoHash that gives you further detail about that location. And you can get the response back in a number of different formats, so if you prefer it in XML, well, you can do that too, and it's often the case of just changing the file extension on the end. So I believe, and I'm going a little bit on the fly here, but I think that if I just swap that around to an RSS feed, yeah, I thought so. So let's just back up and check. What I meant to do was send it to JSON. There we go. There's the JSON results. So the data gets parsed as you wish in that query. So you can do a number of things. You can get information about a postcode here. You can find the nearest postcode to a point, or you can find all the postcodes near to another postcode or point. So it's quite a powerful little API, although quite simple in its approach. So let's look at how we'd communicate with it using FME. So there's a couple of different options here. Let's have a look at one of those to begin with. So we'll have a look at the find the nearest example. So I'll just launch Workbench and let that refresh on your screens. So you can see here again we're using this mechanism to create a feature. In this case these are just some dummy locations. So creating some locations, giving them an ID and extracting a set of coordinates from those locations. And using a little favourite transformer of mine, the attribute reprojector, taking the X and Y that is in British National Grid and turning that into latitude and longitude. So it's a handy little tool, the attribute reprojector. And then I'm using a string concatenation process to effectively build the request to the API in the structure that it requires. So we put in the URL, the fact that it's a lat long, the coordinate values, comma separated with a CSV on the end, and then we'll get the string that we require. We're then going to hit the API using the URL that we've built to get back some information via the URL contents. So in this case, if I just disable this process and connect an inspector and prompt and run, you can see that I've set up a number of parameters to go and search around pubs and shops for the nearest postcodes within a mile. So if we run that, and in this case we have a series of points on the map, and now you can see that in the URL contents we have a series of strings bringing back information, and there you can see we've got our postcode being brought back. So we can then use this process to find the nearest. So now that we've got a postcode near to a point, we can pass it in, and this time we can send it against the find the nearest. So we send it to the nearest API URL, put in the postcode, the number of miles we're interested in, we're passing it in a parameter, and get the data back in XML. So you can see the approach. You're constructing the URL that's required in order to get the data back from the process. Another very similar scenario is a way that you can validate your data, in this case validating a postcode or a zip code or any kind of information against a definitive data set or a definitive set of content that is available at the end of an API. Again, the same technique. We trigger a feature and fetch some parameters. In this case, we fetch a postcode that the user has entered. You'll see that if I prompt and run, we can punch in a postcode. And the key thing here is that we're preparing for the potential that the user may enter an incorrect value. So in this case, whilst this is actually a valid postcode, what you can see is that there's a series of spaces that shouldn't be in those locations, and they've put it all in lowercase rather than uppercase. In order to handle that problem, we fetch back the parameter and put it straight into the UK postcode validator, which is a transformer that we built and have made available via the FME store. in order to access transformers on the FME store, you'll notice that if you go into the transformer gallery, you should have a number of transformers that are available to you. Ones that have the little green download button on them suggest that you can download them, and they're effectively available from the FME store, which if I just go and pop that into a URL and bring that into you to see, you can see that the URL is store.safe.com, and you can go and have a look at some of the transformers, the formats and the templates that are available to you to download. You'll notice that a precursor to one of the examples I'm going to show you in a moment, some of the all-time most popular items, the Google Geocoder, the vertex counter, the polyline analyzer and also the attribute concatenator, are custom transformers that have been created that you may be interested in. The Google Geocoder one is a web service category, and that's what we're going to come to shortly. Just as a top tip, if you do have access problems to the FME store, one thing you may want to look at is your FME options. And you can see in here that under network you might have to put in some proxy details to get past a firewall that perhaps is blocking access. One for your IT guys if you need to deal with that problem. So UK postcode validator checks to see if the value in the postcode field is valid. If it is, then we can have it reformatted, and we're passing it through, and in this case making sure that we've got no spaces in the postcode, because the UK postcode validator puts the spaces in the right place, but actually the API requires that there are no spaces in the postcode, because spaces in a URL are never too handy. And here we're passing it into the location. Incidentally, one thing to bear in mind is that there are a lot of HTTP transformers that have been combined within FME 2015. So all of the capability that you can see in the HTTP fetcher, as you can see on my canvas, is actually bundled up in the new transformer, the HTTP caller these days. So from that you'll be aware that, or you can surmise that actually this is a workspace that was written in a slightly older version of FME, because it has an older version of the transformer in it. What we're doing when we get the information back is we're building some of the URLs. So for example, the openly local URL, the UK postcode URL, suffixing with the postcode so that we've got clickable links in our target format. If we get the data back as JSON, we can flatten it out, and you can see that in this case we're also creating a point on the map for that location. So in this case, if we run this, it should pass it through to the API, get back all the details about the validated postcode, and put it on a map, and it turns out that we're down in Cornwall. If we select the feature, you can see that we've got the geohash URL that we've created, we've got the details of that site. We can go and have a look at the UK postcode URL in here as well. So if we pop this up, there's that roadworks, bring that in, and there you can see the space has been taken out, and now we've got the detail about this particular postcode. So, little validation process that communicates with the API as well. Just tidy the screen up a little bit. NHS Choices is another API that's available. This is effectively what the NHS are referring to as syndicated content. So this is data that you'll know is always up to date and always correct. If we bring that key page in there, you can see that there's details about the syndicated content that's available. There is a huge amount of data available via the NHS Choices API. You need to apply for it as an organisation or as an individual and create yourself an account. But once you have an account, you can start to do pull requests against the data. In this case, you'll see, for example, that we're passing in the URL to a particular service type. This is A&E locations, this service type, within a certain distance, in this case 40 kilometers of a postcode, and we pass in the API key that we've got. So what we could do is, if we go and have a look at a particular example, you can see that we've got the request and we've got the results, and the results within 40 kilometers of CB4 for accident and emergency locations. You can see that there are 3 of them in the term of hospitals, and we can go and find out more detail about those. We take a look again at how that's interacted with via FME. What we can do is bring in a little workflow and drop that onto the canvas. You can drag and drop F&W files straight into Workbench, as I just did there. And again, the same technique, creating a trigger feature to allow other transformers to do something. And in this case, we're building a URL. We're deciding what range you want to search within, and what postcode you want to bring back, and what format you want to write out. And here we've got a little slider that we can use to determine the distance around the area that we're searching. And then what we're doing is building the URL in the same way. So we've captured the content that's being passed in, we build the URL into a long string, and again we're going to pass that in this case to a feature reader, and the feature reader transformer is going to read the XML from the data set that we're passing in, i.e. the URL that we've constructed. We bring back the data, flatten it out, and in this case we're writing it out into KML, and there's that attribute reprojector again that's flipping the coordinates that I've passed in this case in British National Grid, sending it back into latitude and longitude, and I'm writing the data out. So if we go and say, go and have a look within 20 kilometers of a Bristol postcode and write the data out, we're going to write that out into some KML. So we'll open the containing folder, and it'll open up on the inspector, but we can also see that we've got some KML, and that's just opening up. I'll just bring Google Earth into view. And we've got a couple of A&E hospitals, and you can see we've written it so that we've got a little bit of detail in the selection. And we've used FME to write an image into the KML balloon, and as well the URL that will take us to the NHS Choices information for that hospital in more detail if we want to go and find out more things like opening times or visitor access. So again, lots of options with how you can communicate with these kinds of data sources. Just on the API side, to conclude really, I wanted to highlight a few transformers that are available in the FME store for geocoding. All of these are custom transformers, and they've been constructed by either safe software developers who wanted to extend a little bit of the capability of the tool, or third-party organisations. So you can see that there is an AGOL, an ArcGIS Online geocoder, that allows you to use your ArcGIS account to communicate with the AGOL API that allows you to carry out geocoding. There's also a GeoNames geocoder, again hitting an API to geocode against that open source naming database. One Spatial has put together an IP geocoder. So if you've got an IP address or a web address that you want to get some geographic information back from, that queries the free geoip.net database that is again accessible via an API. The Google Geocoder and the Spectrum US Geocoder, again the same capabilities, different data coming back, different environment and capabilities, but all accessible via a FME store transformer. So let's have a look at what that can actually do for us. One thing to be aware of is that you must conform to the rules of the API in the communication, but also in what you do with the data. So it's necessary, if you were to use the Google Geocoder, I believe that the API dictates that any results that you produce are displayed on a background map that is a Google map. It seems acceptable that would be the case if you were using their service. So do read the details and the documentation around an API. You'll see here again I'm just using a creator. I've created a little address attribute just to put a constant value in here, in this case just an address of our office, and I'm just passing that in to the Google Geocoder, and I'm using an address format that is freeform, and the address is included in there. So if I run that, send the address, it has been geocoded, the inspector launches on screen, and hopefully it's going to put us somewhere in the Cambridge area. Okay, so the location type is approximate, it gives us a lat long, it gives us the detail of the full address. If we just zoom in here, we should get some map data back, and there you can see that's roughly where our office is located. So in this case, if you can take the address string and paste it onto a Google map and do a query for the address, you're likely to get an almost identical result via the Google Geocoder API. So interesting transformers, go ahead and have a play with them. You can see that if I just spell ArcGIS correctly, there we go, ArcGIS. There's a few different ArcGIS online API or services here. You can see there's one for the geocoder, the GeoEnricher, and an assortment of others available to you via these custom transformers. If you edit a custom transformer, you can generally see that there's another workspace tucked away in there. So that's where the magic happens inside that transformer. Just moving over, shifting our attention towards the end of the session to web services. Web services, as I mentioned, are subtly different, and one example is the data share from the Environment Agency. This serves up environmental data from DEFRA and its agencies, and you can see there's the ones that are involved are listed along the bottom there. And we can use this service to directly inspect the data, or we can consume the data into our FME workspace and do something with it. You can see here, if I just click the link, we can go and have a look at the main site, and you can see that we can go and get a WMS or a WFS. The trick to these services on this site in particular is that down at the bottom of the page there is a URL that is being constructed as you click certain layers on the page here. So if we go and search for something like sites of special scientific interest, we can see that we have reference to a number of SSIs. There we go, that's the one I wanted, so if we go for that one, and we'll go and have a look at special protection areas, and we'll go and look at Ramsar sites as well. So these are proposed Ramsar sites, areas of wetland importance. As we click these links, our URL is being constructed at the bottom here, and then we could go over to the data inspector, and if I open up a new connection and we'll go for a WFS, paste in the URL, click the feature types that are available, and you can see that the 3 layers that I chose are available to me here. And I might go and have a look at the special protection areas. Make sure that your max features does not constrain the volume that you might be bringing back, so just be aware of that. And we'll make a connection here and drag the details back over the web. So we'll let that get on with it. That's just polling the service. So all those agencies are serving their data here, and that will allow you to consume it into your process and write it out to whatever format you wish it to be stored in. Other types of web service are data feeds, raw data feeds in this case. So data.gov is a good data.gov.uk is a good location to go to find some of these feeds. There are a huge amount of them, and a lot of the data is served up as XML. So, for example, we can go and look at some of the live traffic information that is being served up by the Highways Agency. You can see this data is being served in XML. This is unplanned events, and you'll see what that is when we look at it in detail. So if we just click through, you can see in here that you have a series of tagging that goes on that determines the type of situation it is. And if we click our way through and just collapse the tags, this will determine how many there are. And some days when you do this, you'll find that there are lots and lots of situation, and some there will be fewer. And you can see there's a lot going on at the moment. So the different types of situation that might be happening, there could be accidents, there could be road blockages on the main highway network. To handle this, we just want to consume that XML. So let's go and have a go at that. So I'll just pop open a process. And the key thing here is that when we added our XML reader, the key thing is that we determine some elements to match, and in this case we also want to flatten the information, the attributes that are coming back. And you have to do that when you define the reader. So if we go into the navigator, you can see in here that for this XML reader we have the URL, the one that we copied out of data.gov.uk, and we are, in this case, elements to match is situation, which matches the element that we just had a look at, and we're flattening out all the attributes. So the result of that is that we can now pick up the attributes like the longitude and the latitude that are stored in here, and we're taking that detail, longitude and latitude, and creating a point, defining the coordinate system, and then keeping only the attributes we care about and reading that in to our process. And now we get a series of situations on the map that we might be interested in taking a look at, and this is effectively current information. There's a bit of an issue on the M42 there. There's some slow traffic, gives us a location, it's southbound, and it determines the capacity and the number of lanes that are available and whether there's any obstructions, and a bit more detail about it. Here we can see we've got a broken down vehicle tag. So this kind of approach to serving data is very popular. There is a huge amount of data available from all sorts of different sources that you can connect directly with using FME, and these are all very handy techniques to apply to your daily processing. No longer do you necessarily need to go to a source, a data source, take a cut of it or take a download of it manually, store it locally, and then transform and restructure it, and then the next time you want to take a feed, do all of that again, or write a third-party process to do that data administration process for you. Here you can connect to the raw data, and as it changes at source, your process can be triggered to run or run on a schedule to process that data. So I hope that was a useful session. What we're doing here is just trying to give you a few tips and tricks to how you can consume data more effectively into your processes, and I'd like to thank you for joining us today. Hopefully you saw a few new examples and a few new capabilities in FME for connecting to APIs and web services. If you want to find out more, then you can go to either onespatial.com/FME or directly to safe.com's website. The Knowledge Centre is very much the main and primary resource for me to direct you to. If you have any questions, you can send those, pass those into the FME community, effectively a chat room that is operated. There are plenty of blog articles, and of course you can look at all our historic webinars and all of SAFE's historic webinars at those two YouTube channels. That's One Spatial Group and also the FME channel. But for now, I'd like to thank you very much. I hope that's been useful, and we'll see you again next time. Take a look at onespatial.com/events for the next webinars that are coming up in this series.